want to refer. Okay, so basically conduction, if it's a insulator, you can think of it as vibration of the atom. So the wave travel from the hot end to the cold end. Or if it's a metal, it's the electron, and the heated part has small kinetic energy, so it diffuses to the cold end. Right? So that's conduction. And convection is the mass movement of molecule. The part that's heated,
Yeah, the sea breeze, land breeze, and
heated,
heating in the fluid.
volume expand, density becomes smaller, so it lighter, it move up. The cold one becomes heavier, move down. So that's the convection current. Then radiation is by electromagnetic radiation. So good, you know that one. This one also, you know that.
Sir, go back again, sir. Okay, sir, can go next question.
Okay, the end of the metal rod of uniform cross-section area is kept at temperature T1 and T2. T2 is room temperature. If the rod is unlagged, which of the following shows the variation of temperature T with distance x from the hot end when steady state has been achieved?
I got correct or wrong, sir?
You got it correct. You got it correct. So this part, if you don't like it, heat is going to be lost at the side there. So the temperature will go down.
Cannot be A1 confirm.
A is if it's lag. Okay?
Yeah, A cannot. Either
Lag.
B or C, but must compare.
So if the surrounding temperature is less than T0, then you will go down to the surrounding temperature first and then come up again.
Answer boy lah.
Answer boy. It go down very fast, it loses very fast if it's unlagged. Not C. This one also okay. Playing with the formula only.
Yeah, P equals to KAG. The G you turn into what theta over X lah. Then you just swap. Actually, the P you can replace it with Q.
Good. This one you have.
Sir, if they put that in subjective, I wouldn't know how to answer. Sir, the number 3.
In an experiment to determine the thermal conductivity of a good conductor.
Sir.
Yeah.
Number 3, right? Just imagine if they put that in the subjective, I will be clueless, sir.
Number 3, what's the problem?
No, because the way they tell, like they want me to solve a question or something, I don't know that they want a derivation also.
Straightforward only, just getting the formula. Some of it are straightforward, play with the formula only. That's all. Instead of P, they use Q, that's all. So it can be confusing, but you have to understand the context, that's all.
Yeah, that's why they say rate of Q lah.
Rate Q is rate, not heat. Rate, not quantity of heat. That is why important, not good. Okay with that?
Okay. Sure, but correct, right? Chapter 11
got it correct. Only number 4, you got it wrong. Right? Number 4, the sample must be
chapter 11 got only 2 formula, right?
Yeah. Just play with the formula and know how to calculate. Long and laggard. Laggard, you don't want the heat to be lost. So you want the heat flow parallel along the conductor, but that's not the real reason. The heat loss from the side of the rod can be corrected.
But A correct, right?
A is also correct, but that's not what you want.
Yeah.
That's not what you want.
Oh.
That's not the reason why you make it long. Okay? The heat loss on the side of the rod can be corrected accurately. Cannot. The temperature
cannot. Sometimes they will be lost.
Temperature grade along the conductor is constant, correct, but that is not the reason.
Did I answer C?
No. Is sufficient large temperature gradient. Large temperature difference is obtained between the ends of conductor to reduce uncertainty in temperature. Right? That's the formula. You want to find K. You have to measure P. You have to measure L. You have to measure A. You have to measure delta theta. So if you choose,
you have to play the formula.
You choose sufficiently thick conductor. Yeah, all right. Right? This one have to go to accuracy there. Delta K depend on the percentage error in P, percentage error in L. L no problem if you make it long. But temperature is the real problem. You want the temperature from one end to the other end, a lot of different. Right? A, no problem because you use quite a thick rod. Okay, donkey, accuracy problem. Okay with that?
Sir, can I explain again, sir? Confused a bit.
Your K, right?
Yeah.
Percentage accuracy in K is percentage accuracy in P, percentage accuracy in L, percentage accuracy in A, and percentage accuracy in delta theta.
Well, okay. Well, why
So if
isn't
it's
it
long,
minus?
if it's long, like 100 cm, then the percentage uncertainty in L is negligible.
Yeah, it has to be meter. What?
Yeah, it doesn't matter about meter because the accuracy in length is 0.1 cm. Okay, now.
No, sir, but isn't it like minus percentage A and then minus percentage
No, minus,
delta
minus,
theta?
all plus, all plus.
How come all
Okay.
plus? Because the below one is A theta. What?
That one is only
right?
for systematic error. Systematic error then is subtract, but random error, no. Random error, you just add them up. Don't get confused.
Random error means whatever. If it's divide or times,
no
also just add it up everything lah.
No subtraction, everything you add up. Okay with that?
Where sir? Then the above one is systematic error lah, sir.
If it's subtraction, then you have is systematic error. But we are not interested in systematic error. We want to make sure that the percentage accuracy is in K is very small.
Okay.
Right, this one also have problem. The end of the well-legged metal rod of length L is kept at steady temperature T1 and T2. T1 is greater than T2. Which graph best represent the relationship between rate of flow, dq dt, and x, the distance from the hot end? If it's lagged, the idea of lagged is you don't want dq dt to be lost. So it means dq dt must be constant. That's the whole idea. Right? If it's lost,
This one I got a bit trick lah.
It cannot be lost one. It is always constant. It is flowing. Just like the water flowing in your Bernoulli in a tube there. Right? The volume flow rate is constant. You can change the size of the tube, you just change the speed only of the water.
And how do we derive it, answer the formula?
No derive. There's nothing to derive.
No, but I can't understand the question.
This one is dq dt is constant one. When it's lagged, nothing is lost. So the heat is just flowing constantly throughout. All right. It doesn't
when lagged, heat is not lost lah.
It's not lost. It doesn't decrease. It's always constant. Okay. This is from your textbook.
Okay.
The ends of the well-legged metal rod, same. This one you want to look at d theta dx and x. So d theta dx is constant. Temperature gradient is constant. Right? If it's temperature, then the temperature decreases like that. This one. But you're looking at d theta dx, that one is constant. Don't get caught. Don't get confused. Okay?
Wait, the before one was delta theta over delta t with x, right?
Previously was dq dt. The flow, the heat flow is constant.
Oh yeah, the rate of time. This one is
the temperature gradient. Temperature gradient is also constant.
Yeah, temperature gradient. The x.
Not theta. Not theta against x. Theta against x.
I mean, this is relationship between g and x lah. Basically, g is delta delta theta or delta x one.
You want the temperature gradient? How the temperature change with distance.
So the x, so they are directly. Wait, are they inversely proportional or directly?
No, temperature gradient is constant.
Constant.
If it's temperature against distance, then it is B. Right? So if you take the gradient, that's your d theta dx. Understand or not? That one is constant if it's laggard.
So answer is C.
Donkey. Okay now.
Okay.
If B is this is theta, this must be theta, not d theta dx. This is theta. Remember that?
Yeah. Okay. Just like what is that?
The
V
gradient
and
is
1 over
constant.
V lah.
The gradient is constant. Don't get caught.
Yeah, they're basically just like PV and V lah. Yeah, right.
Okay. That's why I say you haven't done the homework. This one is all taken from the book.
Over delta X and X, you compare it with PV and V, right? It's something like that, right?
This one we are looking at d theta dx, not theta
No.
against x.
Just comparing, yeah.
Not theta against x. Theta against x is will be B.
Yeah, delta theta over delta X against X. What I'm trying to say is that means it's like something similar to the graph of PV against V, right? That's what I'm asking.
dq dt, like it's just like dq dt, that's all. I'm
Yeah.
confused what you're talking about. The gradient is constant. Doesn't change. Okay. This one you just calculate using the formula only, calculate for each rod.
Compare both lah.
No, not compare, you just add them up.
Yeah.
Just use this formula. Calculate for the thin rod, the top one. Put in the what is given there. Then the thick rod, this one. Done it in class with you. Calculate out. And then add them up. The flow is just a water flowing in each of the tube, that's all. Add them up. You get that?
Yeah, this one I got correct.
No, you got it correct, man. I thought you got it wrong.
No.
Okay, you got it correct. We have done in class anyway. I just changed the answer only.
Yeah, you just changed.
This one is the same thing. It's just a trick question. The flow rate.
This one I got correct, Archer.
This one we can look at that.
Oh no, I got wrong. I put A.
Number 8, you got it wrong. Number 9 also got it wrong. Number 7, you got it right. Right? This one they use R instead of P. Right? The flow rate doesn't matter about the area. The flow rate you cannot control it. Is determined by what you put in. You put in exactly must come out because nothing is lost. But the temperature gradient will change. That's all. Play with the formula. Right? R is the one that is constant for the whole rod. Your K is constant. It depends on the rod, the same material. So A and M will change, that's all. If A is smaller, M will be larger. That's all. Yeah. At X, M is smaller. At X, A is smaller than at Y. So MX is greater than MY.
Wait, okay, Rx equals to Ry, okay, makes sense because A is constant. Like why Mx is more than My, huh?
From here, yeah, from this equation, this one is constant, K is constant, so it means A and
Correct.
M is constant.
Constant also.
So if A is smaller, then M must be larger. Right? Inverse proportion.
Oh, you mean you make it A equals to 1 over M lah, like that?
Yeah. You can see yourself. A is larger, N must be smaller here to make it constant.
A smaller. Oh yeah, that's why the X one, the A is smaller, that's why it's increased lah.
Yeah.
Okay.
The end of the metal rod is kept at temperature T1, T2. When steady state is achieved, the variation of temperature along the rod is shown by the graph below. Which of the following about the rod and room temperature T3 is correct? Okay, it goes
I
down.
knew the answer was either was that C or donkey, right? The answer.
Either one. So you want to know T3, the room temperature is going to be less than T2. That's why it has to go down. He has to lose the heat to the room temperature, and then after that pick up the heat again. Okay with that?
Okay.
Okay, let's go to the next one then. In Lee's method to determine the thermal conductivity of poor conductor, the sample is in the form of a thin disk. To produce small temperature difference, no. Thin disk got its reason to reduce the heat loss from a large surface area. Right? Basically, there's going to be heat loss on the side here, but because the amount of heat flowing is large, the heat loss is going to be small. See, so that the rate of heat loss can be measured. That one, whether it's lost or not, we can measure, not see. So the temperature gradient is large. Okay, so answer is C. So that the rate of heat flow can be measured. If it is
Yeah, that's why I answer lah.
if it's too thick, too long, heat take a long time
Cannot measure.
flow. Take a long time to flow.
Insulator lah.
It has to be thin. B is wrong. Heat loss on the side is negligible as the surface area is large. So most of the heat flow through the surface here larger than what is lost at the side there. Okay.
Okay.
This one, two-legged rod P and Q of the same length are placed with ends at 100 and 0 degrees as shown in the diagram. The diameter of P is twice of Q. Thermal conductivity of P is Q. What's the value of the ratio of the rate of heat flow? Same as the previous one we do, but just needed to do a little bit of calculation, the extra calculation, use the same formula, use the area there, and then write in terms of the diameter. G is constant, same temperature there, same temperature gradient. So what is a variable? P K D squared. That is for rod P, is for rod Q. And then you want the ratio of P to Q. Write down P to Q. Take the PQ down. Take the KP up, which is that. Take the DP square up. So you got that. Then put in your value. What is given? Can? Answer B. Play with the formula only.
But what I did was right,
Yeah.
The first one I did P equals to KAG lah, for the P, not the Q. So P, what I did was, because can't they say the thermal conductivity of P is quarter, right? So I put like 1/4 Ka times 100 over X lah. Cannot like that.
If it's a quarter, that is a quarter. It's a quarter.
Yeah, sorry, 1/4 times 2 Ka
So
times 100 over X. They say diameter is twice some more.
Q like BK, then P is a quarter. That's what it is. Okay.
Okay.
Aluminum rod of length X and metal rod length B have the same cross-sectional area and are perfectly legged. The ends of the rod are maintained at the same temperature T1 and T2, where T1 is greater than T2. Rate of heat flow in both the ends are the same. What is the value of X over B? Okay, let the length be X, let the M be B. Same temperature, different. So play with the formula only, same thing, same formula. Right? Yeah, total same cross-sectional area. So for aluminium, put in the formula, what is given. Then the rate of heat flow in aluminium is the same as the heat flow in metal, right? Because the same temperature different. And let them be equal. There's aluminium. That one is for the metal. Right? Metal is 86. T1, T2 is the same. And the length is B. A is still the same. Cancel the A. Cancel the A. Take the X across there. Cancel T1, T2. Take the 86 down. You got that? Calculate out. Lo. Okay.
Teacher, I wanted to, yeah, the answer I put D lah, correct lah, teacher. I got
Okay.
2.78. Teacher, but my question is like the 86 I can put the other side also and the 240 the other side also, right?
It's your metal. Try which one you want to work first. When you look at metal equals aluminium also can. Doesn't matter.
I mean, you can put like 240 times with the T1 minus T2 over B or this one, right? Vice versa also can, right?
Not sure what you're talking about.
No, Che, you see, Che, the 240 times T1 minus T2 over X, right, Che, times A.
Yeah.
So my question is like, because we don't know like where exactly does the metal and aluminium belong to. So like what I'm asking is like, can I replace like 240 with 86 and then the other side I replace 86 with 240?
But your X and B must also change.
Yeah lah.
Same, it doesn't matter. You just shift it over the other side, just turn it around, balance as well. Doesn't matter where you start with.
No, just asking.
It doesn't matter. This is a math problem. Okay, we have to change in a while. Two different metal rod of the same length and cross-section area are joined in series and legged. I think this one, yeah, all right. When steady state is attained, temperature at the opposite end of the composite rod is 110 degree. Conductivity of P is twice that of Q. So you just let the center be theta. Right? The flow rate is the same. You're just playing with the formula. Flow rate is the same. Calculate for P. Calculate for Q.
Answer is boy.
Cancel the common factor. Ka, L and K cancel off. Okay, good.
Oh, Che, I think I almost got it wrong, Che.
Yeah, cannot afford to be careless.
No. Do you know how, Che? I did the method correct, but the 2Ka I put it on the other side. Like
So I say you have to be
2Ka times
careful, cannot
theta
afford
minus
to be
10.
careless. Okay, let's go to the next one. This one, yeah, okay.
Che, can you go to the previous one again? All right.
Okay, this one, yeah, all right also. I just change the answer, that's all. It's legged, it's either C or D, that's all. And then you look at the conductivity. You are told that same length, same cross-sectional area, legged, thermal conductivity of K is half. If conductivity of K is going to be half, is smaller, then the gradient is going to be less steep. Okay.
Did I get this correct, Che?
Did you get it correct? Let's check.
Because I did so many of this, I also forgot which one is which
This number
already. Did I get
14.
this correct? I knew the answer was either donkey or C, but I'm not sure
14,
which
you
one I
got it
put.
correct. Yeah, you got it correct.
Okay, thank God.
The reasoning is right.
Okay.
Okay. The
Because like I just did comparison only lah.
yeah, it's just comparison. Look at the gradient only. The
Mm.
gradient of x is steeper compared to y. So gradient steeper. That's all. K is smaller.
Mm. Okay, next question can ready, sir.
This one is if it's a laggard, it's a straight line. If it's unlaggard, it's a curve. That's all. Okay with that?
So go previous one again. Hey, why boy? Isn't it? What's that? Because they say only P is lag. Okay.
P is laggard, it must be a straight line. Must be a straight line.
Or not C or B.
P
Yeah,
is the
it's
one
either
where it's
B
a
or
curve.
C. Definitely not A or donkey.
Okay with that?
C curve, man. Acha, what did I put B? Acha, the answer.
Number 15. 15, yeah, all right.
Oh, I got correct, huh?
You got it correct. 16, you got it wrong. The others, you got it right already.
Okay. So just give me 1 minute.
Our time is running out already. You have to change the zoom in a while.
No, my computer battery went low. Just give me 10 seconds. I'm
Okay,
already there.
okay, you better charge it up.
Okay.
Okay, this one I think you got it wrong. Which arrangement would not increase the heat transfer by convection? Air conditioner is fixed close to
Boy
the
is correct. What? So it's not the answer.
A is correct. B is correct. Ice that float in the glass of water. Ice, the part water near the ice there will be cold, so it will sink to the bottom. So correct. A heater is fixed close to the ceiling. No, heater you must put on the ground, not ceiling, because it will heat up the air. Air becomes expand, becomes lighter, move up. So answer the wrong one is the donkey. Okay.
Oh. Oh, I
Okay. The
put
window is
C. I
forced
know A and
convection.
B was correct.
Okay with that?
Yeah, okay.
This one you got it correct also. Which of following incorrect? Sea breeze.
Oh, I got this correct.
A, yeah. Sea breeze is not forced convection, it's natural convection.
Yeah,
Sea
it's natural.
during the
It's not
day.
like external.
Okay,
Okay.
18 just using the formula only, that's all. And put in your value, calculate out. Can
Oh, it's 1 minute.
just playing the right formula, that's all. I think you got it right.
Not really. Yeah, but the formula was totally wrong, especially the area part lah.
Then how can you get the right answer? You put in the wrong formula.
Objective much.
Objective is simply tembak. Don't know tembak.
Yeah, this one I simply temba.
Oh, like that, you tembak correctly lah.
Yeah, sometimes lucky lah. Okay, next question can ready.
This one also the same thing. use a formula. Surface area is 4 pi r square. Calculate your surface area, put into the formula, calculate your T. Answer C.
Okay.
This one you got it right also, so you won't bother. Okay.
Okay.
21, you are a bit lost. Global warming. Earth is warming up due to heat from the sun. It's warming up, it's losing heat from the sun, so it's all right. Forest fire cause warming of the earth. No, it is not because of that. The earth is warming up due to greenhouse gases reflecting the heat from the earth back to the earth. That's the reason. Right? Normally, you want the heat to be lost. The sun hit the surface, you want the heat to be lost. But the greenhouse gases will reflect the heat that's supposed to be lost back to the earth. That's the reason. So you warm up the temperature of the earth. Okay?
Okay.
Okay, take 5 minutes break. Then we carry on what topic you want after this.
Topic 1, topic 2, topic 5.
Topic 1, topic 2, topic 5, what do you mean?
Chapter 1, chapter 2, chapter 5 lah. Oh, you mean one chapter only ah?
What do you want to do after this one? Anyway, you decide and let me know. I have to finish already. This one I have to close already.
Okay, ni je. Okay.